Hello all, good evening. Welcome to my YouTube channel all about VLSI. Hope you're all doing good. I hope my voice is audible and my screen is visible. Yes. So let us start today's session. So before going to start our session, please make sure that you have subscribed to our YouTube channel all about VLSI. Okay? Yes. So today we are going to start about the topic called full wave bridge rectifier circuit. So in our previous session we have completed with the topic called full wave rectifier and half wave rectifiers, and in this session we are going to discuss about full wave bridge rectifier. Okay, yeah, so let us start with this full wave bridge rectifier. So what is this full wave bridge rectifier? So full wave bridge rectifier, the typical circuit of full wave bridge rectifier look like this. So in full wave rectifier we had only two diodes. Okay, so if you remember in our previous session in the full wave rectifier we only had two diodes. Okay, but in this full wave bridge rectifier we have four diodes. Okay, so in this four diodes, two of the diodes will be positive biased and two of the diodes will be reverse biased. Okay, so when the positive half cycle of the input is appearing, two diodes will act as in a forward bias condition and two of the diodes will act as a reverse bias condition. Okay, so two diodes will work as a forward bias condition and two diodes will work as a reverse bias condition when the input positive phase has been occurring, and if the negative phase occurs, then the diodes which are acting as a forward bias will become reverse bias and reverse bias become forward bias. Okay, that we will discuss in detail. Okay, so typically we have four diodes. So this is the typical circuit of a full wave bridge rectifier. Now let us see the operation of this full wave bridge rectifier. So the diodes are arranged in this manner. So here D1 is present, D2 is present. So D1, D2 are parallel to each other and D3, D4 are parallel to each other. Okay. Now, whenever our input voltage is applied, if you can observe our D2, here our D2 and D4 are forward bias. When the input positive voltage is applied, from the figure if you observe, the current is flowing in this direction. Okay, the current is flowing in this direction. The pink line if you observe, this is the direction of the current. Okay, here if you observe, the current is flowing in this direction. So if you observe the current direction, the voltage is flowing from D3 and D2, D4. So it will become positive bias and D1, D2. So here D2, D1 will be positive bias and D3, D4 will be reverse bias. I will write it here. 1 minute. So I will write it here. When the input cycle is positive, when we have a positive input cycle, our D1, D2 diodes, D1 comma D2 diodes are forward bias. Okay, and the current will conduct through this diodes. So D1, D2 are forward bias, so the current will flow through this particular diodes. So in the forward bias, what happens? The current will flow through this D1 and D2. If you observe, the current is flowing from D1 followed by this and followed by our D2. So it is making a circuit. It is starting from here and it is ending from here. So D1 and D2 will conduct and D3 and D4 are reverse bias. I will write it here. This is for positive input. It is for positive input cycle. Okay, and D3, D4 are reverse bias. D1, D2 are forward bias as well as D3, D4 are reverse bias. Okay, so this is a working of positive input cycle. What happens when negative input cycle? When negative input cycle occurs, then the diodes which are acting as a forward bias, D1, D2, will now act as a reverse bias. So this D1 and D2 will become reverse bias and D3 and D4 will act as a forward bias. This D3 and D4 will act as a forward bias and D1, D2 will act as a reverse bias. So what happens if they are working as a reverse bias diodes? Then no current will flow through this D1 and D2. If you observe the current direction, the current is flowing from D3 to, it is flowing through this junction and it is reaching to, sorry, this is D4. So it is flowing from RL to D4, D4 to D3, D3 to ground. This is the current flow. It is not flowing through D1 and D2. So this is the flow of the current when our D1 and D2 are forward bias. Okay. So when there is a negative phase, then the diodes D1 and D2, I will write it here, D1 and D2 will act as a reverse bias diodes, and they will not conduct the current, and D3, D4 will act as a forward bias current. D3, D4 will act as a forward bias diodes. Okay. So if you observe the output waveform, for every input cycle, whether it may be a positive or a negative input cycle, you are getting an output voltage. Okay. So this is the working of a full wave bridge rectifier. So for positive phase also, for positive input phase also, you are getting the output, and for negative input phase also, you are getting the output. Okay. So for every input, whether the input may be positive or negative, we will get the output. Okay. So this is the working of full wave bridge rectifier. Now, so let's see the bridge output voltage when we consider the diode to be a ideal diode. Okay. So when D1, D2, D3, D4 are ideal, let's consider these diodes as ideal diodes. Okay. Then what happens? The output voltage, peak voltage, VP out, will be equal to VP secondary voltage. That is a voltage which is present here at the secondary side of the transformer. Okay. The transformer voltage, how it is getting, that we have discussed in our previous session. If you haven't watched that, please go back and rewatch that. Okay. So here, the voltage which is present at the secondary side of the transformer is called V secondary. So the output voltage, the peak voltage VP out, which is equal to VP secondary. Here we are considering the diode to be a ideal diode. Okay. We are considering the diode to be ideal diode. What if the diode is not ideal? That is, we are considering if the diode is a practical diode, then there will be a voltage drop across this diode shed. There will be a 0.7 volts drop across this diodes. 0.7 volts drop across this diodes. So in the practical diode, there will be a drop. Then what happens? Then peak voltage VP out will be equal to VP secondary minus 1.4 volts. Okay. So this is how. Why 1.4? Here the two diodes will be conducting, not only one diode. When the forward bias, when the input voltage is when there is a positive input voltage, then two diodes will be conducting. That is, here D1 and D2 will be conducting. That is VP secondary minus 0.7 minus 0.7. That is VP secondary minus 1.4. So at the output, if you observe, so let's say this is the input. Let's say this is the input. Let's say it is VP. Then the output, it is subtracted by, let's say this is VP secondary. Then at the output, there will be a small decrease in the voltage. Okay. Sorry, I'll draw it once again. Here there is no change in the here there is no change in the frequency. Okay. Frequency changes. Here the frequency doubles, the full wave rectifier frequency doubles, but the amplitude, if you observe, this is the input voltage. Okay. This is VP secondary. That is the secondary voltage which is present at the secondary side of the transformer. Now here it will be VP secondary minus 1.4. So there will be a little decrease in the amplitude of the output voltage. Okay, it will be like this. No negative phase, only positive phase will be occurring at the output. Okay, so this is how. And remember, the frequency increases, not decrease. There is a change in the frequency. The frequency doubles in the full wave rectifier. The frequency doubles, whereas in the half wave rectifier there is no change in the frequency. But whereas full wave rectifiers, we have already discussed, the frequency doubles. Okay, this is the output. So there will be a decrease in the amplitude of Vp secondary minus 1.4 if we consider a practical diode. If we consider a practical diode, that is a 0.7, if we consider a 0.7 barrier voltage across a diode. Okay, so this is how we are going to analyze a output voltage of a bridge wave rectifier, bridge wave full wave rectifier. Okay, so this is about full wave bridge rectifier. Okay, so with this we have completed all the three types of rectifiers. We have completed what is meant by full wave rectifier. We have started with the discussion of what is meant by half wave rectifier and what is meant by full wave rectifier, and we have also discussed what is meant by full wave bridge rectifier, and we have also seen what happens to the output frequency of a half wave rectifier and what happens to the output frequency of a output voltage of a full wave rectifier and a half wave rectifier. And in this session we have completed with the full wave bridge rectifier. Okay, in next session we are going to discuss about clippers and clampers. Okay, yeah, so that's all for this session. Thank you. So if you're having any doubts or queries, you can just ping me in the comments. I will try to answer them. Okay, yeah, thank you. So if you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you.